Hello, in this video we will go over the properties of similar polygons and use that information to figure out missing side lengths. So, similar polygons. What's the difference between a congruent polygon and a similar polygon? Uh, Something I want you to know. I mean, something I want you to ask when we go over this. So similar polygons are polygons for which corresponding angles are congruent and all corresponding sides are proportional. So that's very important. In a similar polygon, not congruent, all the angles must be the same and their proportion must be the same. That doesn't necessarily mean that their side lengths are all equal. It means their proportions are equal. So as you can see in this polygon, ABCD, and you have this little symbol, and as you notice, there's no equal sign that means similar to polygon EFGH. Okay, as you can see, all the angles, this should have one mark here, all the angles are congruent. Uh, and then the proportions should be the same. They don't give you an exact, they don't actually give you an exact actual side lengths, but proportion must be the same. And then angle A must be congruent to angle E, and angle B must be congruent to F. Angle C is congruent to G, and angle D is congruent to H. Basically, all the angles are the same. Ratios and proportions. If A and B are two quantities that are measured in the same units, then the ratio of A to B is the same. So they're just saying the proportion must be the same. If you see this two dot, that means proportion, or you can write it as a fraction. So an equation that equates to ratio is a proportion. Properties for proportion, you probably know this from college algebra. If A over B equals C over D, what you could do is cross multiply if you need to find a missing X. Right? So AD equals to CB. And then you can also say A over B equals C over D. That's the same thing as B over A equals D over C. So when a proportion, you can set it up any way you like, as long as the sides are the same. I mean, the corresponding is related to the other side. So for example, what if you're dealing with units and you're dealing with proportion? You probably remember this from algebra. This would be I'm not sure. Maybe this could be in feet, and then this could be an inch. On the other side, this also has to be feet, and then this has to be inch. So it doesn't matter how you set it up because you could set it up inches over feet, but this must be inches over feet. Okay. If A over B equals C over D, then A over C equals B over D. If A over B equals C over D, then A plus B over B equals to C plus D over D. So let's do a real simple, let's do a few examples of proportion. So this one says solve the proportion. So it's already set it up. They don't give you an image. How would you do this? You can cross multiply, right? So when you do cross multiply, 7 times x is 7x equals to 5 times 4 is 20. And then you solve for x by dividing both sides by 7. And you get x equals 20 over 7. Okay. Question 2, we have 7 over 6 equals 3n minus 10 over 4 plus 10. So what you could do is cross multiply. So 7 times 4n, 7 times 4 plus n equals to 6 times 3n minus 10. And when you FOIL this out, this is going to be 28 plus 7n equals to 18n minus 60. And then what you would do next is solve for n. So Maybe I could subtract 7n from both sides. You get 28 equals to 18 minus 7n is 11n minus 60, and then add 60 and 60, you get 88 equals to ln. Divide this by 11, n equals to 8. Okay, so that was 2. Example 3, same idea. You want to solve for x, so you can cross multiply. Go ahead and cross multiply. So this is going to be x times x minus 2 equals to 9 times 7. Okay, so go ahead and cross multiply, FOIL this out. This is going to be x squared minus 2x equals to 9 times 7, 63. And then what you're going to do is get one side 0 by subtracting 63. So you get x squared minus 2x minus 63 equals to 0. And then when you FOIL this out, you get x minus 9, x plus 7, and you get x equals positive 9 and x equals negative 7. So this is very common to have two different x values. So uh, what I would do is if you have more than one x value possible, I would plug it in and check it. But there's one you can just eliminate. It doesn't make sense to have an x that's negative length. So I believe it's going to be 9. And if you don't believe me, just plug it in. So it's going to be 9 over 9 equals to 7, and then 9 minus 2. And that gives you 1 over 1, which is true. Okay, this one says express each ratio in simplest form. So we have this triangle, or this, I see two triangles. The small triangle would be this one, and then the big triangle's the whole thing, right? So what does x over pz equal? So xp is, where's xp? The reason why I don't see xp because this point here is p. So the length of xp is 4, and then length of pz is 8. So 4 over 8 is reduced to 4, which is 1/2. And then what's the length of pz over xz? Pz is 8. Xz is the length of xp plus pz, so that's 8 plus 4, 9, 10, 11, 12. And then that could be reduced by what? 4? So that would be like 2/3. Okay, what about the length of ZQ? So ZQ is, oops, length of ZQ is ZQ6. And then the length of QY is, oops, QY is 3. Okay, 6 divided by 3 is 2, so that works out. What about 7? QY over ZY, so QY is 3, and ZY is 6 plus 3, which is 9. And then divide this by 3, so that is going to be 1 over 3. You can also express 1 over 3 as 1 colon 3. right? That's the same thing as a proportion. Uh, 2 can also be expressed as 2 colon 1. Okay, so let's look at this example. True or false? We have you have these polygons, and we want to know if these values are the same. And I want to, everything looks good. So is question A correct? Does AC over DF equal to CB over FE? So AC is 3, DF is 4, and then CB is 6, and then FE is 8. Is this true? Yes, because 6 over 8 could be reduced by 2, so that would be 3 over 4, so definitely true. What about this one? Length of AC. AC is, where are you? 3 over CB, which is 6. And then FE is 8. And then DF is 4. Is this true? I think that's false because 3 over 6 can be reduced by 1, 2, and then 8 over 4 is 2. No, that's definitely false. Number 9, does AC over AB equal DF over DE? So AC is 3, AB is 6, DF is 4, DE is 8. So 3 6 can be reduced by 3, so that's 1/2. And then 4/8 could be reduced by 1/2. That's definitely true. Okay, what about 12? Does angle A over angle B is the same thing as angle E over angle F? I don't I don't think so. Let's see. Does angle A over angle B? No. Mm-mm. Angle A has 2 tick marks. Angle B has 1. And then angle E has 1. Yeah, angle E has 1 tick. There no, that's not congruent, right? So that would be false. What about 10? Angle A over angle C is congruent to angle D. So if you look at our image, angle A has 2 tick marks. Angle C has no marks. And then angle D is 2 tick marks. Angle F is 3. Wait, so I think there should be, because this is one, I think there should be 3 tick marks here on angle C. So I think that's true, right? Angle A is angle A congruent to angle D? Yes, because I know they have 2 tick marks. And then is angle C congruent to angle F? Yes, because there's 3 tick marks. So that's definitely true. 13. Length of AC over AB plus BC equals DF over DE plus EF. So AC is 3. Um, AB plus BC, so 6 plus 6. And then DF is 4. And then DE is 8. And then EF is also 8. I So when you simplify this would be 3 over 12. and then this is 4 over 16. I believe so, because if you divide this by 3, you get 1 over fourth. And if you divide this by 4, you get also 1 over fourth. So true. Okay, this one. This one says use the diagram and given information to find the unknown length. Given that AB over BD equals AC over CE, find BD. Okay, so we're gonna have to set some kind of proportion, and this is what they give us. Um, find the length of BD. So uh, they set it up already, so that's good, but usually they don't. But let's just set it up exactly how they want it. What's the length of AB, which is 20? What is the length of BD? I'm not sure. We'll call it our unknown X. And then what's the length of AC? AC is 15. And what is the length of CE? Okay. Um, yeah, so what is the length of CE? Oh, because I'm sorry, this is my fault. CE was actually given. Yeah, CE was given. That was my fault. I didn't put that in. So CE is going to be 9. So now all we got to do is find BD, which is our X. You can call it X or you could call it BD. It's up to you. But X is considered our BD. So this, if you cross multiply, this is going to be 15X. And then 20 times 9 is 180. Divide this by 15, and you get 12. And then X is BD, so BD is 12. Okay. That wasn't too bad. That's how you pretty much solve set up proportion. So how, like, if you didn't know, like sometimes they won't be nice. Um, you see that there's two triangles in this image, the smaller triangle and then the big main triangle, right? This whole entire triangle is one big triangle. And then all you got to do is set it up. So 20 in the small triangle, 20 would probably be considered the hypotenuse. And then BD is uh if you look at the main triangle, BD would be mm, see. So this is hypotenuse, and then AC is would be a leg, and then CE would also be a leg. No, actually, so see AC. Yeah, never mind. You can't. I think they did it the way this was just given. Sorry. So I thought you could. Yeah. This was given. So let's just move on. Okay. So this one says use a diagram and use the diagram. Whoops. Use the diagram and given information to find the unknown length. So here we have this shape, and Yeah, here we have the shape. We are given that BT over TR equals to ES over SL. Find the length of TR. So that they give us good instruction. Want us to set it up like this. So what is the length of BT? BT is this length here, which is 4. What is the length of TR? TR is, oh, unknown, right? We don't know. We'll call it X. You can call it X, you can call it N, you can call it anything. What about ES? ES is this length, which is given as 8. And then SL is, where are you, SL? This length, which is 10. Okay, go ahead and solve for X, your unknown, by cross multiplying. So X times 8 is 8X. And then 10 times 4 is 40. Solve for X by dividing this by 8. 40 divided by 8 is 5. So the length of TR, don't call it X, but just call it TR, the length of TR is 5. So yeah, it's pretty good if they tell you how to set it up. Let's look at the next example. So in the next example, we're given LJ. They wanted to set up like this: LJ over JN equals MK over KP. Find the length of JN. So yeah, this one's nice because it's already set up. Let's see here. So let's find the length of LJ. So what is LJ? Where's LJ? Blah, blah, blah. Where is LJ? Oh, so it's sorry. This is L. So LJ is what? This length here, but we have too many unknowns. Let's see. Maybe we could figure out what JN is. JN is X, and then MK is 12, and KP is 9. We can't say for LJ, we cannot say X because that would cancel out the X. What we could do is we know the length of LN is 16, right? The length of LN, this entire length here is 16. So we know that LJ is going to be LJ is going to be what? This length, 16, minus JN, right? So that is LJ. So it's going to be 16 minus X. Okay, and then go ahead and cross multiply. So this is going to be 12X equals to 9 times 16 minus X. Okay, so 9 times 16 is 144 minus 9X. And then this is 12X. Solve for X. So you're going to add 9X, 9X. What's 12X plus 9X? 11, 21X equals to 144. Divide this by 21. Divide this by 21. And you get 144 over 21. Unfortunately, doesn't come out nicely, but you can divide this by 3. So that would be 48 over 7. So X is technically Jn. So Jn is going to be 48 over 7. Okay, that wasn't too bad. So more theorems is it states that if two polygons are similar, then the ratio of the length of the two corresponding sides is called a scale factor. So this in a similar polygon, the scale factor must be the same. So here we have these two shapes. Let's call this shape one. It looks like some kind of trapezoid, right? Or so we'll call this trapezoid one and then trapezoid two. And it looks like you have this height and it looks like some kind of base, right? And then over here, it's also a height and a base. So yeah, this one says determine if the polygons are similar by finding the scale factor. So the scale factor must be the same. Uh, if not, then they're not similar. And they're all also, in order for it to be similar, all the angles are the same. As you can see, they're all 90 degrees, so that's good. So now we just got to prove the their proportions are equal, and that means they are similar. So it looks like some kind of square or rectangle. Or yeah, it looks like a rectangle. So this could be the height, and then this could be the wait, this could be the base. So you can set up however you like. So you could put height here and then base here. On this other image, this also has to be height and base. So if you look at this image one, what is my height? 14, and then my base is 10. So if you look in image two, the height is 21 and my base is 15. Are these the same? Does 14 over 10 equal to 21 over 15? Um, I write this right? 14, 10, 21, 15. Yeah, 14, 21, 10, 15. So are they the same? Can we reduce probably? What's 14 over 10? Can be reduced by 2, so that would be 7. 10 divided by 2 is 5. Over here, this could be reduced by 3. So 21 divided by 3 is 7. 15 divided by 3 is 5. Yes, they are the same. And as you can see, all the angles are congruent and the scale factors are the same, right? Now, can you set the scale factor? You didn't have to set it up like this. You can set it up any way you like. As long as this is the same as this, like the measure, this has a height, right? So you could have set it up as base over height, and then this also has to be base over height. It would give you the same answer. So yes, all angles are congruent and same scale factor of 2 to 3. I mean ours was 7.5. So yes, it is similar. Okay, so similar must have the same angles and their proportion must be the same. What about this? Example 18. Are these two polygons similar? So I'm looking at the angles. I have one tick mark here, and then this is one tick mark. And then you have two tick marks. That means this is congruent with this angle, right? So it looks like all these angles are the same. Now let's look at our proportion. So how should we do this? So maybe we could do leg over hypotenuse. And then in this image, this triangle, it also has to be a leg and hypotenuse. So the leg is, and let's call this image triangle one. The leg is 3, and then the hypotenuse is 4. And over here, the leg is 6, and the hypotenuse is 8. Is this the same? Let's see. 3/4 can't be reduced. The 6/8 can be reduced by 2, so that's going to be 3/4. Bingo. So you could say, yes, both polygons. Since all angles are congruent and same scale factor. Or 3 to 4. Yeah. Right, so let's move on to 18. Oh, I just did 18. Sorry. Let's move on to 19 then. So are these two polygons similar? So, ooh, um, you have these two parallel sides. Let's see if I'm missing any. So let's just look at these angles before we determine if their proportion are congruent. Let's look at the angle. So here we have 50, we have 130. Um, I need to know what this angle is and this angle is. Yeah, that's a big no right now because like this angle 50, in order for a polygon to be similar, all angles must be congruent. This angle 50 should be the same thing as 40. They're not the same, right? 50 does not equal to 40. So you could say that's an automatically no. I don't even need to find this, right? Because they have to be the same. Um, so angles are not congruent. It means okay. Okay, let's look at this. Polygon looks like some kind of trapezoid. Let's look at the angles. So remember this is like flip rotated, so you have to understand that this angle is actually related to this angle, and you see how there's one tick mark there, that's good. And then this angle is actually related to this angle, and they're the same because there's one tick mark. And then this angle, I believe it's yeah, congruent to this angle, so that's good. and then this one, yeah, is congruent to this angle because there's two tick marks. So it looks like the angles are good. Now let's check the proportion. So this is a trapezoid. This could be base one, or and then this could be base two, and then be careful with this one. 25 would consider be this base one, and then this would be. Maybe I won't use this. This could be, yeah. So this side, yeah. So how shall we set it up? I know. Maybe we could set it up like this. Base one over this length here, because I can't use this base because this is unknown. So I'll do 8. And then if you look at the second image, base one is going to be 25. And then one of the side length is 8. I mean 10. So are these the same? 20 over 8 can be reduced by 4. So 20 divided by 4 is 5. 5, 8, 8 divided by 4, 2. And then 25 could be reduced by 5. So that would be 5. And divided by 5 is 2. Hello, it's the same. So that means they are similar. Since all angles are congruent and scale factor are the same. Okay. Okay, let's do a few more and then we'll end it here. Let's look at 21. Are these two polygons similar? So I think so. If you look at this angle, there's one tick mark here, one tick mark here, and then they don't give us what these two angles are, but they're going to be congruent because there's nothing here. See, there's nothing here, nothing here. That means that this must be equal to this. So, um, ooh, no, actually, that's false. In order for two polygons to be similar, we have to know that all angles are the same. We only are given this angle, which is congruent to this angle. We can't assume that these two angles are congruent. So, because we don't have enough angles measurement, we could say not enough information about angles. So, uh, yeah, you could just say not enough information. So yeah, don't do what I did. Assume that these two angles are congruent because they have nothing. We can't assume that. Okay, 22. Here we have this triangle. Um, yeah, I think you have one tick mark, two tick marks. Yeah, and I'm gonna say yeah, all the angles are all congruent. Now they don't tell you that this angle, they don't tell you this angle, but let's pretend this was 30 and then let's pretend this is 60, right? That means that this angle here was 30 and then this angle is 60. Now, could you find this angle? Yes, because it's a triangle and all angles of a triangle add up to 180. So you could figure that out. 60 plus 79. This should be like, let's pretend this is 90. So that means this should be 90. So that means this is why all angles are congruent in this case. And the other one, there was two missing angles. So we didn't have enough information, but this one we did have enough. Now let's look at the proportion. What side lengths are we getting? 25 is a leg, 40 is a hypotenuse. Oh, yeah, we're good. So you can set up like this. Leg over hypotenuse. Leg over hypotenuse, right? So if you look at this triangle, the leg is 25, and then the hypotenuse is 40. If you look at this triangle, the leg is 5, and then the hypotenuse is 8. So 25 over 40, I believe it could be reduced by what? 5? 25 divided by 5 is 5. 40 divided by 5 is 8. And then this 5/8 can't be reduced. Hello, the proportions are the same and the angles are the same. That means thus it is similar. And then the same proportion of 5 and then comma 8. I mean, yeah, semicolon. Okay. Let's do a few more. 23 says, given the polygons are similar, find the indicated measure. Triangle TED is similar to its triangle SAM. Okay, so here you have a triangle. What do we do? Oh, this was different. So what we got to do is figure out, um, let's look at EA. Uh, what should angle E be right here? So this is simple, right? You have two angles, 80 and 70. So all you got to do is do 80 plus 70 plus angle E. And we all know that adds up to 180. And 80 plus 70 is 150 plus angle E. Subtract 150, subtract 150, and you get 30 degrees. What about angle A? Okay, so they're saying that these two triangles are similar, and we know that in similar triangles, all angles are the same. So angle A, what is this angle? It's related to angle T, so that angle A should be equal to 80, right? Wait, be careful. This is kind of, see how this is sideways? Angle A is actually 30. Angle A is related to angle E. So angle A is actually going to be 30. And then angle, what about C? Line segment SA? SA. So it's this length right here. So we would set it up as x over 18 equals to 5 over 15. Yeah, so I'm going to set it up like this, and then if you cross multiply, this would give you 15x equals to 18 times 5 is 90. Divide this by 15, you get x equals 6. So I'll say it's 6. What about d? What is the length of Sm? Where are you, Sm? Oh, that's given. Sm is 5. Yeah, Sm is 5. Okay, let's do the last one. So they're saying that polygon ABCD is similar to polygon EFGH. Uh, oh, are they asking? Yeah, are they saying that these are similar? Oh, I'm missing a few notes. This length here is y plus 3. This length here is x minus 2. So, uh, what we got to do is, it looks like the angles are all good, right? One angle A is congruent to angle E, right? Angle B is congruent to angle F. Angle D is congruent to H, and angle C is congruent to G. So it looks like the angles are the same. But is our proportion the same? I'm not sure. And then they give us this length EH is y plus 3 and length EF is x plus 2. We need actually values, right? So we got to somehow figure this out. Like, we got to solve for our unknown variables. So how we're going to set this up is we're going to set it up like this. What are we given? Oh, why? This is length AB is 6. Sorry about that. So how should we set it up? So we could do this length, 6, and then that's related to EF, which is x minus 2. And then we could do 8 is related to line segment EH, or y plus 3. How is this going to work? Yeah, this is not going to work out. We're gonna have to probably set up two proportions. Oh, because we have two letters, right? We can't just, it will not work. Okay. So 6 over x minus 2. Okay, so maybe we could do this length, AB and EF. So that'd be 6 over x minus 2. And then what would be our scale factor? So before I should have done this, what would be our scale factor? Our scale factor would be um can I put I missed this is also 15, sorry. FG is 15, so this was given. So go ahead and re-look at this image. We have the length of AB, which is 6, the length of AD is 8, the length of BC is 10, the length of EF is x minus 2, the length of EH is y plus 3, and then the length of FG is 15. This was all given. So what is our scale factor? The only actual measurement is we could use BC is related to FG. So BC is 10 over FG is 15, and then that could be reduced by 2. I mean, 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So it looks like we have a scale factor 2. So we can say 6 over x minus 2 is going to equal to 2/3 because that's our scale factor. Now, we got to somehow solve for y, so we're going to have to set up another proportion. So how should we set it up? We could do 8 over the 8 AD is related to EH, right? So that's like y plus 3 equals to the scale factor 2/3. There we go. So let's go and solve for our unknown variables and check if its scale factor is the same. So over here, let's cross multiply. 6 times 3 is 18. And then this is going to be 2 times x minus 2. And then cross multiply. So this is 2x minus 4. Add 4. Add 4. You get 18 plus 4 is 19, 20, 19, 20, 21, 22. Equals to 2x. Divide this by 2. X equals 11. Over here, I'm going to cross multiply. 8 times 3 is 24. And then 2 times y plus 3. Boil this out. This is going to be 2y plus 6. Subtract 6. Subtract 6. You get 18 equals to 2y. Divide this by 2. Y equals 9. Okay, so we got our y value is 9 and our x value is 11. So that now we can plug that in to figure out if our scale factors are the same. So y was 9, so this would be 9 plus 3 is 10, 11, 12. And then x was 11. So this would be 11 minus 2, which is not, what's 11 minus 2? 10, 11. I think it's 9. Yeah, it's 9. So the length of EF is 9. So let's see if his scale factors are the same. So we could do 6 to 8. 6 over 8 is the same thing as 9 EF to EH, 9 to 12. So 6 over 8 can be reduced by 2. So that would be 6 divided by 2 is 3. 8 divided by 2 is 4. And then 9 over 12 could be reduced by what, 3? 9 divided by 3 is 3. 12 divided by 3 is 4. Hello. The scale factors are the same, and the angles are all congruent. So you can say yes, uh, they are similar. Okay. Okay, that wraps it up for similar polygons. I'm gonna stop here.